How's everyone doing? It is Sunday. We have a printer, or no, Saturday. Saturday. Weekend's not over yet. It is Saturday, and we have a printer to finish. Or at least get the mechanicals of it done. So today, we're going to get the bed installed and move on to the gantry. And then hopefully we'll push to start getting the electronics in so that next week we can do some wiring. So we'll see how far we get tonight, see how things go, and we'll move on from there. So how's everyone doing tonight? Let's see here, make sure I got everything. Help if I opened up the manual. Okay, so let's see, where did we leave off? I believe we were at installing the bed, and we stopped there because I had to do some modifications to it, which are done now. So let's see, so we have the panels on, we have our A/B drives, we got our front idlers in. Got that one. That's installed. That's installed. Oh yeah, pocket watch. We got to do the pocket watch. We'll come back to that later. Okay, so the bed. So for the bed, I've gone ahead and oh yeah. Keep forgetting the colors on this camera. Always reset. 1 second here. Proper white balance. There we go. Okay, so originally how this bed was set up was that I had just holes drilled through it, and they were tapped M3, and the screws would come up through the bottom and screw into the bed, and that would pull it down onto the springs. So that was early, how it was way back a year and a half ago when this thing was first being designed. So now it's obviously just countersunk holes with screws, so we're going to put those in right now. So it calls for putting your 3 screws in and then using an M3 nut to kind of lock them in place. Not too bad, Ross. It's Saturday, it's the weekend. Yeah, the apron, I'm completely shameful, or shameless. It's pretty much the one Adam Savage was using. You know, literally the day after I bought it, he put out a video saying, "Oh, hey, I made my own better one." But this is the one he was wearing for a bit. And it just, you know, as somebody who loses everything on the table I'm working on, it's nice to kind of have pens and the common stuff always on you. Plus, I'll cover it one day, but my workbench here is wood. I've just kind of built it out of some, you know, 2x4s, 4x4s, and some plywood. So I was actually getting shirts caught on the edge and, you know, little rips and whatnot. So I figured, get a leather apron, stop damaging my own clothes. Plus I've got metal chips in it. You know, you're drilling or tapping something, you get metal chips in your clothes. That ends up in the wash. That's not good. So it is sanded. It's not, you know, it's not a rough edge. It's mostly just the surface on it. It's a workbench. Okay, so slide these up. Okay. So, for anyone who hasn't installed the bed before, let's see how good of an angle I can get here. Here, I'll do it backwards. There you go. Now you can see. So, you have this little hole here. This is where your wires run through. So just kind of feed them through. And it is kind of a tight fit, but they do fit. You might have to like tug them one at a time, but they do all fit through. And then, if you didn't know, these springs, if you go on like Amazon or whatever, these are the generic Ender 3 bed replacement springs that's what they always list them as. You want the yellow ones. If you get blue springs, they're going to be way too tight. So actually, I'm going to pull this out and redo it, because as you can see, the wires are twisted. And if you put your wires in and they're twisted, it's going to be even tighter when you go to pull them through. And it won't look as clean. There we go. Actually, no, I don't have a fuse on this bed yet. I gotta do it. I'm being bad. You should put a fuse on it. But at the moment, I don't have a fuse on the bed. I'm being bad. All my other printers do. I don't really run this guy unattended for the most part. And I've had zero issues with any of the other beds, and it is only like a, what? That's 100 watt. You should be getting a 60 watt, by the way. This one's overpowered. There we go. Okay, so once you get your wires run, you drop your bed on. Hello, 3DP Memish. Now, when you push down on the bed, you should feel the screws just pop out of the bottom. Okay, so they are 35 millimeter long screws, and depend on how hardcore you go with your counterbore or countersink, is basically how much they're going to stick out. So what you're going to want to do is basically push it through. It's going to be kind of hard to focus, and then put your knurled nut on to hold it down. Now, I don't know which one. These are definitely not the spec ones. These are just some low profile ones I've had for a while, and I'm just using them to use them. There we go. Okay. Kind of awkward to do for the camera. So. So the updated parts, Pablo here is asking if the updated T88 lead screw parts are mandatory. If you are running, or if you are changing the lead screw and the nut you have to the new spec, then yes, you will have to reprint them. If what you currently have is working, and by working I mean you're not having lead screw wobble, you should be okay. Basically, it's an update to try and help alleviate the lead screw wobble issue some are having. So what the update is instead of I think T88 or T82, it's now T88 is what we recommend. And it's a lead screw nut with an anti-backlash spring mechanism in it. So for example, I don't have either of those, so I'm not using the new parts. So only print them if you have the new parts. And if you are, if your current machine doesn't have lead screw wobble and everything's working fine, I wouldn't really bother personally. Yeah, that's probably... There we go. Okay. So, the bed is now installed. Fancy. And now we got to run the wire, so I'm going to move my bed up a bit here so I have a little bit more room. And I'll go over the cable management, which is really simple. Okay, for the wiring on the V2.4, do you recommend using terminal blocks or connecting the main power? Are you talking about where you have like your mains power go to a terminal block, and then from the terminal block you go off to wherever you gotta go? Is that what the Yeah, so personally, I run everything direct. So, for example, I run my my mains line from the inlet directly to the power supply, and then I run lines from the power supply to whatever needs 24 volts. And for example, on my switch wire, I have a line that runs from the inlet to the 24 volt power supply, and then that same mains line now jumps from the 24 volt to the 5 volt. So I just daisy chain everything. You don't need to run with terminal blocks, but they can be used. They can make maintenance easier, and they can help make it look a cleaner build. So if you have them, or you want to use them, by all means use them, but they're not required. I don't have them, so... And plus, pretty much all my builds are non-standard builds for the most part. I'm not even gonna. Zishi saying, how can the T82 lead to Z wobble while the T88 doesn't? I'm not 100% sure because I don't even know which one I have. I think I have a T84 2 start of some random kind. I you know, again, bought in the early days of dev when we didn't have a standard. But apparently it doesn't wobble as much. I think it has to do with the fact that when you attach the 20 tooth on the bottom with the belt, there's more contact surface, or I'm not 100% sure, but it doesn't wobble as much, so we're going to recommend it that way. Until there's a better solution, that's what we're going to go with. So, for the wires, if you look on the underneath, there's a little channel. So your wires come out, and you're going to run them through this little channel and then up through your drag chain. And try and keep them from like twisting and whatnot. Just makes it easier to work with. Okay, now for these little ones, I'm actually going to put a little tape on it just so it feeds through better. Somebody did do a mod for a belted Z already. I've seen it. But it's I don't know what state it's in. It's a mod. But there are other things kind of in the works. It's just kind of, it's so tight and compact. You really can't, there's not a lot of room. It's not like, you know, everywhere else we just recommend, you know, if you're running lead screw, you just run an integrated lead screw. Because if you buy a good quality integrated lead screw, like with that's a motor with the lead screw built into the stepper, usually you don't have the wobble issue, because the wobble is coming from something introducing wobble into the system. So, fortunately the printer is so small. That's why I hate these ones. The 7.7 drag chain don't open, so you got to feed everything through it. So if it catches, some tweezers or whatnot would be your friend to pull it through. Damn it. Okay. There we go. So you're going to want to feed it into the channel. So don't be afraid to pull it a little tight. And then zip tie everything together. It comes down to size. Basically, with how compact the stock configuration is for like where everything's located, there's really not a lot of room to work with when it comes to what you can put in where. But if you do want, if you're okay with moving a lot of stuff around, you can fit like an integrated stepper in the bottom. But you're gonna have to get bigger feet. You're gonna have to move some stuff to the back, electronics wise, because. So this is our bottom, okay? Let's see here. So you got, how does this go? That goes there. Your power supply goes there. You have a buck converter here. You also have a fuse or an SSR here. And then you're going to try and fit this here. Right about there. It doesn't quite fit. Plus, you don't really have a lot of depth to work with. Because it bumps everything out. There's some stuff being looked at, and if anything pans out, it will let you know. Somebody's already redesigned the Vzero to work with 2020 and NEMA 17s already. So I think that's the Tiny M mod. So if you look into that, you might be able to glean some ideas. I'm not sure what they did for Zed, but there is a mod for the V0 to make it use 2020's MGN9. It's basically kind of like a step up from a V1 at that point. Together. There we go. So now we have our Z chain in, all the wiring's in. So we're going to take this time, we're going to move the motor or the bed back down, and then move on to the gantry, I think is next. One single bearing block to hold the entire lead screw in place. There is, see here. There's a pillow block bearing on the bottom, and then on top here there is another bearing press fit into the printed component. So there is a bearing on each side of the 22 to keep it straight. Like mine, when I could feel it when I go up and down, it feels smooth, like I feel no binding. You can reference it against like a known component and see if it's wobbling. And I did check mine. I don't, pretty sure I don't have any wobble, but it's kind of hard to see until you're actually printing. So that'll be something when we go to print. If it's wobbling, we'll try and fix it together. Okay. So bed's on. Oh yeah. So I forgot. You have to tighten the M3 nuts. Under these guys. There we go. Because if you don't tighten the M3 nuts, when you go to tighten the little knurled nuts on the bottom, you're not going to move your bed. You're just going to spin the screw. Now, personally, it says use any screw. I personally, like, this is my own, what I would recommend. I'd recommend using, like, a flathead screw. Just for the fact that you can leave more meat to the bed. Because you're only... Okay, so the machinist talk time. Difference between a counterbore and a countersink. Counterbore is for a screw that has a cap head or a socket head. A countersink is for a taper. Okay? So if you're countersinking something, it's a tapered cut. If you're counterboring something, it's a flat bottom cut. Okay? Now you can use a screw, you can just use a drill bit for either of these. It's close enough for what we're working with, but you don't have to take out as much material to get this screw head under the surface versus this one. And since we're only using a 1/4 inch aluminum bed, personally, I like having as much meat as possible with aluminum, holding my bed in place. I don't think anyone's going to screw up and take too much off, where after time you're going to stress the metal and you're actually going to pull the screw head through the bottom. I've seen that happen outside of this, like in work and whatnot. I've seen that happen with material failure with design, but I haven't seen that happen with anyone's done that yet with a 3D printer. So just one of those things to kind of keep in mind. I don't think it'll be an issue unless you really drill, unless you pull a Dwarves in the Mine of Moria and go too deep. I don't think it'll be an issue for anyone. Okay. Yeah, never with lead screws. Ball screws are different. If you're running ball screws, you're supposed to have captive both ends. Lead screws, though, you only want the bottom captive. Okay, you want the top wobbling, because if your motion system is rigid enough, it'll basically counteract as much of the wobble as possible, because the lead screw will just kind of wobble, and if there's enough play in the nut, it's still pushing up and down, because it can only move up and down on your motion system. So if your motion system has a lot of play, that's where you see lead screw wobble is most visible in beds that are cantilevered, where, like on the Vzero here, where it's only on one end. So if you have a wobble here, okay, the further you move out, the more pronounced it's going to be. Okay, basic math, right? So beds that are supported on four corners, you won't see it as much because you have more rigidity to your bed. Okay, now if you had super high quality linear bearings that didn't have a lot of play in them, you probably won't see as much lead screw wobble. But this is a cheap compact printer. I'm not expecting anyone to buy, Misumi bearings or, any of the other high-end quality linear rails. So it's all about motion and constriction, and you're not really going to over-constrain anything probably, but okay, so let's go back to the manual. Where were we? Paul, just wanted to tell you in person how much I appreciate all your videos. My V2 is alive and now printing, no tuning yet, and your videos are a big part. That's good to hear, man. Glad to see it's up. Well, glad to hear it's up and running. Get that serial in soon. And for tuning, I do have a video on how to do pressure advance tuning. So watch that, follow the steps, and we'll go from there. So when this guy is up and running, I will go through the whole first boot, what you should tune and what I think what order. So that'll be later on. So that should apply to all Vorons, but I'm going to be doing it on a Vzero. Okay, so let's see here. To the manual. Oh, okay. So for those M3 nuts, it says apply Loctite. I didn't, but you can. If you torque a screw to the proper rated torque, it shouldn't come loose. For the most part. It's, depending on vibration and all that stuff. Okay, if Y carriages are not installed, install them now. Done. Install the rails. Okay, that's the... So it looks like we're putting the gantry together right now. So we'll put this guy aside. I'm running out of room. As you can see right now, I got Tall Boy's back up on the printing desk, simply for the fact that it now has a bed. So I'm going to be filming the serial video for that guy tomorrow, hopefully. And remind me at the end of the stream. I want to go over flex plates because I kind of think I figured something out with the energetic flex plates and why some people are having issues with them. So remind me to go over that later. You plan to make some videos on Switchwire? Yes, I will be doing some videos on the Switchwire. It's a much simpler build than any other Voron, so I don't think I'll tear mine apart and go fully in depth, but I'll do a video where I just have it out and I'll go over everything or any questions anyone have on it. Okay, so we're building these. Okay, this is going to be fun. Okay, so get my box of printed parts. Okay, so we're going to need a bunch of washers, some shim, bearings, idlers, all the fun stuff. XY joint assembly. So we will start with this one. Okay, so M3 nuts. Howdy, silly llama. And hello, DJ. Okay, so M3 nuts go in the holes. Okay. And then M325 come up through the bottom. And the bottom is this one. And we got to build some bearing stacks. Okay, so do the back one first. So it looks like washer. I need to get a longer cable for my little key deck here. 1 second. Okay. So we got washer, bearing, washer. What is that? M355 washer. Oh, that's another washer. Ooh, do I have that little washer? I don't know if I have that super little washer or if I just use 2 bearings. Or if my washers are small enough. We will see. Yeah, I think I just used normal washers there. We'll find out if it's too tight. So, washer, bearing, washer. Yeah, you could probably get by with the M35s. I think these are M37s everywhere that I have. Yeah, they're 7 mil. I think I'll be fine. If it's an issue, and actually what I'll probably do is, because I don't have them, go back here. Yeah, I think if I just eliminate one washer and just let it float ever so slightly, I should be fine. because I think that's how I had it originally in my build. But that was with beta parts. So I'm not 100% sure if that'll be an issue. We'll find out. If it is, I'll swap it later. I'll order them. And if it's not an issue, I'll just leave it. Okay, so on this side, we got a printed 2 washers, a bearing, 2 washers. Probably want to see this. Like, the reason for the different IDs is because the bearing on these 2 Thidlers are so small that we're using washers so that you can actually compress them and the bearing will still spin. Where if you use too big of a bearing, you're actually going to be pushing against the flange and it won't spin. So, okay, so now I got to put these 2 parts together. That goes there, that goes there. Why is that being tight? Ah, crud. 1 second here. Oh, I grabbed the wrong one, that's why. That's why that wasn't lining up. Yeah, okay, that's why that wasn't lining up. I'm like, why is my bearing sitting on plastic? That ain't right. There we go. Okay, so. And then we have a, there we go. So. That moves freely, and that one's locking up. So if I just loosen that ever so slightly, yeah, that's still locking up. So yeah, so I'll probably hunt down those bearings, swap them out later. Okay, and now we need some self-tappers. Where are my self-tappers? There we go. Tag lead, update on your dual extruder. It's printing. I don't know where I have. Did I put it away? Ah, it's upstairs. It's functioning now. It's not Still not 100%, but it's at a state where I'm kind of like happy with it, for now at least. I haven't really played with it much this week, so if you watched last week's video with the little cup I printed with the 2 plastics, that is the most recent dual extrusion print that I did on it. Okay, so that bearing was fine. This one's still tight. So yeah, I probably will have to swap these out. Now, I could have sworn I had some. Just take a minute here and look. No, those are M2. No. Let me see over here. I think these are them. Yep, there we go. Yeah, I do have them. Okay. Aren't lost yet. Can I print some washers? I probably honestly could, but I'm not going to. I'm trying to do this, you know, the right way, guys. As I try and jam parts improperly ordered together. Screw it. Take it apart. Do it right. Do it right. Okay, so we got are these? Oh, you know what? These are M2.5 washers. They're not M3. One second. Yeah, they're not even the right ID. They are 5.8. And I can't have any bigger than 5.7. Do I want to try drilling these out? I could YOLO it and just drill them out. No. So what we're going to do is, just for the sake of getting a video out, I'm going to build it without the washers altogether. And I'll swap them out later. I'm going to definitely recommend you guys use them. But sure, you guys don't want to see a 20-minute video today, so I will come back on my own time and fix this. So pretend I'm doing this right now, guys. Yeah, so I'm just going to run it without a washer for now, and I'll swap it in later. Could have sworn I had some. Yeah, I'm gonna hope Amazon Prime has some, and I'll just prime them. And if they don't, well, we'll either roll the dice or I'll swap it to smooth idlers. Because honestly, smooth idlers have been working just fine on my V2s and switch wire. Because switch wire is all smooth idlers. There's no tooth idlers anywhere in switch wire. And honestly, it works just fine. Oh, I grabbed 35 mils. Shit. Wrong size screw. $25 mil. There we go. Yeah, 25 mil, not 30 mil. Okay. M2 self-tapper. Do I recommend any post-processing like drilling out holes or sanding plastic parts for this assembly? So what I've always recommended is if your printer can print a hole, fine, and the screw fits through, you don't need to drill it out anymore. My V2 is tuned for printing plastic parts for Vorons, right? So I can literally take parts right off it and put them together. Now what I do recommend though is anytime you have large mating surfaces, so for example, grab it here, like the two halves for the tool head, where you have, you know, a large section of flat plastic that they sit against each other. What I do recommend is you don't really need to sand it, but just get like a file, which I keep this bastard file on hand, and just give it a quick rasp 1 or 2 times. Just to knock off any, you know, little errant blobs or anything that just sometimes, you know, your nozzle leaves a little blob or something. That's all you really need to do. As long as your printer is like fully tuned and everything should go pretty much right together. You shouldn't have to be doing a lot of post-processing to get everything to work. Okay. What is smooth exactly? Smooth is when you put them together, you don't have air gaps. You can't see light through them when you screw them together. Oop, almost dropped my water bottle. So yeah, when you screw them together, if you don't see light gaps and, you know, stuff isn't stressed, you should be fine. Oh, smooth. So for idlers, you can get smooth idlers and tooth idlers. So if you have, like, you see them a lot in Vorons, because we use them a lot, is you just take 2 flange bearings, you put them on top of each other like that, so the flanges are out, and your belt runs in the middle. That's a smooth idler right there. The advantage of using stacked bearings over like store-bought smooth idlers such as here, like these guys. This is like a tooth idler. But if you look, it's big and chonky. But if you look how small the bearing in these guys actually are, and they're usually pin bearings, so these have a tendency to kind of explode after a while. So we recommend using high quality ones like Pouch or the E3D ones in the Vzero, because we only need 2 of them. But like the cheapy little no name brand ones that you buy on like Amazon or AliExpress for like 10 cents each, these guys explode like no tomorrow. So try and avoid them, or at least avoid the cheap ones as much as you can. Okay, so we have these assembled. And now we are putting it on our extrusion. And it's M312s on the top. So that one goes there. And that goes on the bottom. Okay. So M312 and 2. I just want to see on the bottom. It's M36, okay. So we got 2 on the top, 2 on the bottom. So I just realized in the, you go back to the manual, for the cross beam, pay special attention. Do not let the carriage slide off the rail. Use zip ties if you need to. It doesn't call out for pre-insertion nuts, but you're obviously going to need to put 2 here, 2 there, 2 there, 2 there. So you can put one side on, and then you'll have to put the other side on. So you're going to need 8 nuts. 4 top, 4 bottom. And on the other side, it's, what do we got? We got M312 and an M325. And then this is where you put your your little end stop block, and this is what your Y end stop actuates against. So 25 mil. And don't worry about the orientation of this for now, because you can adjust this to adjust the trigger location of your end stop. So we'll just leave it flush for now. Okay, flip it over. Put the bottom ones in. And these ones are M312, I believe. Let's take a look here. Yeah, M312. Or correction, M36, what did I say? There we go. So now I can get rid of the zip tie. Because now my rail won't go flying anywhere. Okay, let me just catch up on chat here for a minute. I don't know what I hit there. Okay, so let's see where we are next. So we got that. Now it says leave all gantry bolts loose for now, which I went ahead and when I built it, it isn't tight, so we're good there. And that's what it should look like, which rotate, pivot, 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 pivot. Yeah, close enough. Okay, so there we are. And now we install it. All these little washers away. Already dropped one bin of these today. Okay, so for installing this, it goes on top, and then a bunch of M28s hold it in place. Has anyone made a printed frame Voron yet? To my knowledge, no. Are you talking about printing like the extrusions? Because that's quite a... it's possible. If you go on Thingiverse, you can find the file for 2020 extrusion. But actually going so far as to actually print the full Voron, yeah, no. I have not seen that. Okay, so right now, just making sure all these screws are loose, and that way when we screw to the carriages, it'll kind of home itself. Let's just make sure here. Yeah, that's good there, that's good there. Okay. I'm going to drop the bed a bit just so I have some more room here. Correct. You leave the gantry loose for now, so that way when you, because right now, like I have some play here, right? So like my gantry, I can, you know, it's not you know exactly size for size with the gap here, and depending on how you cut your extrusions, if you got them cut yourself, if you the vendor was off a millimeter, as long as they're all the same, it doesn't matter. So you can be off, you know, a millimeter here, a millimeter there, as long as they're consistently all out a bit. So obviously you're not going to have these in the right position. So now when I screw in one and then I screw in the other, they'll just go to where they need to go, and then you just kind of center it, and then you're good. And then you tighten everything. Yeah, it's a weird oddball size, and the only reason we have to spec that size for that location is the tooth idlers, because they need them. Otherwise, they bind up, as you can see. And then also for screwing into your carriages, you obviously well, not obviously not common knowledge, but basically you want to ensure that you put all your screws in first and then tighten them. And you really want to make sure you're not putting screws that are too long in. If you do, you can bottom out the threads, and there's not a lot of thread in these carriage blocks, and if you bottom it out and rip out the thread, you're not going to be replacing it. There's no way you're fitting an M2 helicoil in. Oh, I'm sorry. These are M2. I'm grabbing the wrong screws here. M2.6, not M2.8. That makes much more sense. I'll go to the wide view. There's really not much to see. McMaster does. I'm pretty sure Fastenal does. The problem is, depending on where you are in the world, a lot of people don't have access to certain items. Like I know, for example, McMaster doesn't ship outside the U.S. anymore. You used to be able to get it in Canada, but now they won't unless you have like a business or like a school or some sort of account. Like they're very stingy with when it comes to shipping abroad. Okay, so we got the one in. So now our gantry is installed. Now we're going to go ahead and see what the next part of the manual says. So installed. Okay, so D-rack. So what you're going to do at this point, yeah, it says D-rack there. You're going to take it, do it this way so you can see. You're going to pull it all the way to the back. Okay, and we're going to D-rack. So right now, as you can see, oh, she's shimming. So, push it all the way to the back. What I do is I push it from the middle, and then you're going to tighten your bolts here. Okay, then you're going to slide it out. You're going to tighten your other ones. And now when you bring it to the back, you take a look. They should be hitting. Now you might have to kind of go in there and tweak it a little bit. But basically, both sides should hit the back at roughly the same time, as close as you can get. Now, if you're playing around with it and you can never get it quite perfect, when you go to belt it, you can use the knobs back here, and that will be able to remove any additional rack, especially after once you put the belts on, you might induce racking. So there we go there. Make sure those are tight. Sure all our bearings are still moving good. Everything's still got movement. Front to back's good. Bring it all the way to the front. And you're going to want to make sure that your rails are located in position so that your carriages don't come off the rails at Y minimum. Y maximum, you want to make sure your limit switch, which is right here, is engaging. So if it's not engaging, you might have to bend the lever a little bit more so it sticks out more. And there we go. And when you're bringing it back and forth, it should feel consistent. You shouldn't feel it binding anywhere. If it is binding anywhere, something's not square. So your frame isn't square. And that feels nice and smooth. The X feels good. I'm happy. Okay. Are these Misumi extrusions? So, let's see here. These ones are Misumi. These ones are Maker Beam. These ones are open build. I have all three in here because I purchased them at various times because when we were going over the design of this thing, it changed multiple times. And me being in Canada, when I originally put in my order, I ordered from Misumi for I think the original 8 that we needed, or 4, with a bunch of other stuff. Now, in Canada, we can get Misumi no problem. The problem is it's like a $30 minimum shipping charge. So a lot of time ordering 1 or 2 extrusions doesn't make sense. So after that, I ordered Maker Beams, and then I needed some more, and they were all out of stock, so I ordered Open Beams. So, I'm not liking this bearing. This bearing's rubbing. I'll play with them all later. Okay. So we have this installed. And now it looks like we're running belts. So I have the belts that I used originally. I'm going to try and reuse them. I'm not 100% sure if I cut them too short. If I did, I'll just get new ones. I have plenty of belt. So we're going to run some belt now. So if anyone's curious about the belt path, it's pretty much that. And a pair of pliers may come in handy here. If I can find where I put mine. There. There we go. And running the belts on this thing is relatively simple. Okay, there's one axis. Okay, now run the other one. There we go. So that is the belts are now run. The orange. So I actually like this orange a lot. It's Kodak. Kodak doesn't have like a color code or anything. Made in Argentina though. I picked it up a while ago. It's a nice orange. I like it. It's ABS. But yeah, no, it's not Prusament. That stuff's like $50 a roll up here. I'm not wasting my money on it. Well, not wasting money. It's good filament. Just, I can't justify it. I honestly, Max, I don't think it's really Kodak. I think it's something else that we paid Kodak 50 cents to let us use their name type thing. Okay, so now we got so our belts are run. Okay, so now we got to put this little doodad on. So, remove printed support part. Oh, that's already done. And then we have M3, 6 from the back. And then these Maker Beam T-nuts. These guys are kind of a pain to find. But they're there. Okay. So we'll grab these guys. Oh, I remember this. Yeah, I might have to. Okay, instructions for belt tightening. Belts must be tight, like not kind of tight, fully tight. Use a pair of pliers to pull the belts. Ends while the T-nuts are semi-tight, so you can feel the teeth clicking through the retention block. Pull them as tight as you can without tearing the belts. Only then should you move to tensioning the knobs. If you don't, you're going to run out of travel on the drive tensioners. After tensioning, then you can trim belts. There's no going back after that step. Retensioning after cutting the belts is almost impossible. Take your time, get it right. I got a feeling I'm going to be running new belts because, as you can see, I don't really have yeah. Well, it would help if I have it sitting on its bearings. Yeah, there's no way in hell I'm going to be able to retension these. Okay, new belt time. Let's see what I got. I don't think I have any more of the good stuff. Maybe I do. No, I do not have any more gates. So, we'll see how pouches. Printer this small. Honestly, the only thing that really matters with your belts, you really want to make sure that you have the your belt 6mm or less. Because if it's wider, it's going to be running on your bearings. Yeah, I'm good. Okay. So I wish I had a stapler. Have you seen my stapler? But the trick is, when you're running new belts, is you staple the new belt to the old belt, and then you pull out the old belt, which will feed through the new belt. So I don't have a stapler on hand, so I'm going to just try and tape it, see if that'll work. With green tape, apparently. Yeah, KVP is good, but they don't ship to Canada. Okay, let's see if this works. Probably not. I probably don't have enough room. Yeah, it ain't gonna work. Pull the belts up. Screw it. Doing this live. Yeah. Oh well. It's not like running the belts in this thing is super time consuming. I'm not super happy with this pouch. Like, it does have the reinforcement. It looks like I do see it on the end. Not as much as the Triangle Labs, the Gates belts. But I think we should be okay. Small printer. I don't run my Vzero anywhere near as much as my V2s. So, should be okay. Yeah, that's enough belt. I've got like 20 meters of this stuff. Oh yeah, switch wire. I built the entire like gantry assembly in like an hour and a half, fully everything. It's a stupid simple build. It honestly would probably take me more time to tear it apart than to put it back together. Yeah, silly llama. I could reuse the belts like that. I'm just kind of screw it. I'm just going to use new belt. It's not a big deal. If I didn't have spare belt, I would be reusing it, but I have tons of it, so. And then, just for those curious following along at home, I do have, I did recently, well, today, I put the new bed on Tallboy there. So I installed the flex plate. So I recorded doing that, so I probably will, hopefully this week. Or, yeah, hopefully this week I'll be putting out a video on how to install, like, your flex plate. And, make sure it's properly installed and how to do it without using like, you know, a rolling press, and how to do it just by hand. Make sure you got no air bubbles, how to properly prep the bed surface and all that before you install it. So I will be putting that video out. I just got to edit it at this point. Let's see here. My AB belt's grinding on the bearings. Do you think the issue with the bearings or the washers? If the belts are grinding on like the flanges, it would be an issue with your belt. What size screws are these? Yeah, M3. Where's my... I always lose my M3 drill bit. M3 drill bit. Where are you? No. Because this one, because it did have printed support, I do have to clean up ever so slightly. No. I have an M3 drill bit. I just don't know where I put it. There we go. Got it. So, little tip, one of those dumb little things that if you have makes things better. You can get these like little handheld drills. They're for like, I bought a kit for drilling holes in PCBs a while ago, but keep like one of these on hand with like a 3mm drill bit in it. It's great for anytime you got to clean up a hole. Or you could just use a drill, but my drill's dead. And I'm not going to go run outside and use the drill press for this. Yeah, you can pop off the front. There's ways of doing it. Again, I'm trying to follow the instructions. That's another reason. So M36 button head. Do I have any more M6 button head? So I've been stealing them to use in other builds for other things, and I think I actually may have screwed myself over and used them all as one. M36. M36. Well, guess I'm using flathead. Sure, it's fine. Yeah, I'll be fine. Actually, no, I won't. I gotta find another M36. Nope. I know I have them in switch wire because I used them for holding down my for my drag chains. So I can always just steal one out of switch wire if I need to. I need to buy more button heads. I'm running really low. Yep, looks like I gotta borrow one from switch wire. I'm back. And I got one there. Nah, I don't want to borrow that one. There we go. I just gotta hope I don't drop them. Yeah, there's really not a lot of room. I gotta clean that up. So this part prints with some support that you need to break off. So you might need to clean it up a little bit. And then also M3 nuts in the bottom. So actually I'm going to go ahead right now. take a break and put these nuts in, and I'm going to super glue them in place. So I'm not chasing them around all night. Because I remember having to do that before. Actually, no, they don't stay in place. A little dab of super glue. Okay, let me just catch up on chat while that's drying. There we go. Let that dry. Okay. When I hand move my X carriage in the Y direction, it's very smooth and light. When I move the tool head in the X direction, it feels heavy and not smooth. What is that a sign of? Well, when you move it, let's see. Well, when you're moving it in the Y, your motors are moving opposite. When you move it in the X, they're moving in the same direction. So it might have something to do with that. Mine feel the same. I haven't really... I would ask in the Discord, see if anyone else has had that issue and what they've done to solve it. Okay. Hopefully the glue's dry by now. I just don't want to be chasing these nuts all over the place, because it's a pain in the ass. Okay, so let's get these belts installed. So, top belt. Oh wow, this is a lot tighter than I remember it being. Yeah, I'm gonna have to clear this out more. Okay, so top belts. And it might help to put a little, cut a little 45 on the belts to help feed it through. Because once you get it started, you can just pull it through with pliers. Yeah, these belts are probably thicker. Don't think that'll be an issue, but we'll find out. Could also be this filament that I use. I don't have it as tuned as my other stuff. There we go. Okay, so that's through. I gotta get this bottom one through. I should have did the bottom one first. For the smooth idler, so it's not quite like the Vzero or the V2 and V1 gantry, where you can just swap to a smooth idler. The belt path is ever so slightly different with these flanged idlers. They're like fatter or thicker or something. It's the same as true on the V1 and the V2 gantry, but it's not as pronounced. Whereas these ones, it is pretty pronounced apparently. If it's an issue, I'll swap. I'm not too worried right now. But if it does become an issue, I will just swap them out. And I'll let you guys know probably by next week if it's an issue. There we go. Okay, so this is why you want a lot of extra belt. So now I can put the clamps on behind. Yeah, I got that all right. And then I'll pull it tight. Yeah, see, there's not really a lot of room there. I'm going to try some 8s here, see if that works. That is way too tight. I don't even think I have 8. Yeah, I definitely got to go buy some screws. Ah, dang it. Open it and cross thread it. Nope. Okay, there we go. Okay, 1. I'm giving cap screws button or socket heads a try. Hoping I got enough clearance. If not, I'll swap them. Chris, $5. Thank you, man. Appreciate it. I hope you're enjoying the stream. As always, any donations go to either streaming equipment or more stuff to build and print and show off on the stream. So thank you very much, man. Appreciate it. Thank you for the $5. One of these days I'll get around to actually having like a little thing pop up on the screen like every other streamer. Okay. Okay, so line your belts up, make sure everything's riding on actual bearings. So I'm going to pull this one tight. And then I'll adjust with the other one. Okay. And again, you always want to make sure you're riding on your bearings properly when you're tightening. And you pretty much want to go as tight as you can by hand. And then everything else is done with the adjustment knobs. Josh, $4.99. Thank you, man. Appreciate it. Yeah, that one's cross-threaded. Dang it. Dang it. Gotta undo this. So if nobody knows what cross-threading is when you basically try and force a screw in something that's tapped and it doesn't quite go in correctly. So usually if it's on an angle is the most common one you'll see, and it's called cross-threading. So you're basically crossing the threads and it's not good. So I think this one's cross-threaded because it won't screw in straight. Now that could also happen factory defect. So get rid of it. That's a better one. Try again. Yeah, it's free Loctite. That's kind of the running joke in the industry. Is just impact it in. You'll never have to worry about it coming out again. Until you have to take out that 1-inch bolt, and it doesn't want to come out. Then you're hating life. I've been there. It sucks. Okay, and M8s don't work, by the way. Forgot how much this part of the assembly sucks. Do I count the gates on either side? I personally don't. I just kind of wing it and then just tension it by hand and then adjust accordingly. I've never really had an issue doing it that way, so I just kind of keep doing it that way. So actually what I'm going to do is I'm using longer screws than you're supposed to. So I'm going to tighten the screws, and I'm going with a file, and I'm going to chop them down a bit. So that way I can use these longer screws and not have to undo it all. Before I do that though, I'm going to put something on the bed so I don't get metal dust all over. That ain't gonna take a while. That ain't gonna work either. Yeah, screw it. It's an issue, I'll deal with it later. This is one of the reasons I don't want to take apart my Vzero. I knew putting it back together would be a pain. Okay. Add that up there, that's there, that's there. That's lined up good. That's good, that's good, that's good, that's good, that's good. Pull those as tight as I can. There we go. Okay. Ben Lee, $5. Thank you, man. Appreciate it. Hope you're enjoying the stream. Safety squints. Yep. Wear your glasses. Yeah, people kept asking to do a Vzero, and I'm like, I already have one. I really don't want to do this all over again. But if it helps one person finish their build, I'll do it. Okay, so we are having a bit of rubbing somewhere. That's that motor. So I'm going to have to adjust my motors because they're not quite sitting exactly where they were before. So what I'm going to have to do is basically just shift the feed gear up ever so slightly, because I can see it catching on the flange. Making a little bit of rubbing noise. least I'm pretty sure that's what that rubbing noise is. There we go. Of course, I probably shouldn't be doing this while wearing noise-canceling headphones. I can't really hear what I'm working on. Yeah, the slow boat from China is a lot better than it was a couple months ago. There we go. No more rubbing on the flange. If you heard that noise, that is what it sounds like when your belt alignment is off and your belts are rubbing on the flange, specifically of like the 20 tooth or an idler somewhere. But usually it's one of the 20 tooth on the motor, because those are the ones that are moved, that you install yourself. So everything else should automatically be in alignment because that's how it's designed. Whereas these 20 tooth on the motors, you're putting them in yourself. So you're going to have to play with them. And if it's rubbing, you're going to hear that noise. It's going to damage your belt. Yeah, that's better. And 3, I'm pretty sure that actually does show up in the print because it's constantly catching on that edge. And I'm pretty sure that will show up in your print. So you will see tooth marks in your print from it, I think. Okay, so let's carry on past this. Oh, put the tool head on. Okay, I don't have the tool head, so we're going to have to build the tool head. To the appendix. We might run into another issue too. Yeah, we'll see. Look at all this stuff we're going over. Okay, so originally I was going to use the E3D threaded tool head, that's what it originally had. Where did I put that piece of junk? On the floor, apparently. So the default cheap solution that works just fine, that's how I ran mine originally, was the threaded heatsink. So you can buy these on AliExpress. Triangle Lab makes a good one. That's the one I'm using, or was using. And it fits in. I'll show you here, because I'm pretty sure I still have printed parts. No, I chucked them. Pretty sure I chucked them. Okay, either way, see here in the manual where basically the nut part is captive between the two plastic halves, and then you screw the body into it. Look at that art there. That is some grade A art. But what happened was I ended up taking the Dragon that I was going to use in switch wire. That was actually, originally the Dragon was going to go in here, but it didn't arrive in time. So I ended up using this guy. And then I was going to swap the Dragon in when I eventually rebuilt this. But then switch wire ended up becoming a thing, so I put it in switch wire. But then I started playing with dual extrusion. And with the fact that a V6 has a PTFE lining more further down, it's actually more conductive to a Y-splitter setup, I think. At least so far in the testing we've done, than like a Dragon or a Mosquito. So I took the Dragon out of that. So now I have a Dragon, and the Dragon's going to go in this guy. So we're going to put the Dragon in. Once I find the instructions for it. Toolhead, Dragon, there we go. M2.5. And there's our showstopper. I don't think I have M2.5 by 12 mil. So I might be installing the actual Dragon at a later date. Nope. Mosquito to the rescue. I have 2. I'll put 2 in for now, and I'll just do it later. So it calls for, oh, you put them in, and then, okay, I see, and then you attach it. Nope, 10 mil. Yeah, the screws that come with the Dragon are, let me find them. Unless I misplaced them. But it comes with 10 mil. That I'm dropping. So it comes with, or not 10 mil, it comes with M2.5. 8 actually. So they are too short to install. However, I can just screw this in at any point. So I'll build it right now without this, and then I'll just prime some to my house. And I'll just screw it in later. So we're building the Dragon hot end without the Dragon. Okay. So put this guy aside for now. So the first thing is we take our 2 halves and we install a Bowden collar, which are these little guys. And by install, you just kind of put it in position. And then you just kind of squeeze them together. And it'll just squish together. Now, with these guys, you do have to install the little stopper part, which is this blue part, first. And they are actually kind of a pain in the ass to get in there. They are really tight. So I end up usually just kind of cheating it and using my vise to press fit them. And these are the Triangle Labs ones, if you're curious. A vise is one of those random tools, and I'm talking like an actual like metal vise, not like the printed one you found on Thingiverse. Get a vise, get some soft jaws for it, bolt it to your bench, even just for like holding stuff while you're working on it. It makes things so much easier. Having just something that's rigid to hold stuff for you makes a world of difference sometimes. Okay, so M325. And a nut. Oh, okay, and then the fans are the rest. What camera you recommend for Octoprint, the C920 or the Pi? Whatever one you can get right now, really. Personally, I like. This is a C920. Okay, the camera you're seeing right now. This is a C920. Okay, I like it. The problem is they're like way stupidly overpriced right now, at least in North America. So yeah, whatever fan you can get, basically, or whatever camera you can get right now is what I would go with. Okay, fans. Where are my fans at? No, I put them aside somewhere. Nope. Where did I put the fans? .24-volt dual ball bearing. And 24-volt dual ball bearing. 12-volt, don't use that. 24-volt dual ball bearing. There we go. So for fans, I run cheapy GD Stein fans because my printers run in a room by themselves and I really don't care about noise. So I just buy cheap fans that I know work. Okay, so when you go to install these, obviously make sure that the opening goes towards the opening. Otherwise your fan isn't going to work too good. And these are just press fit into position, and you're going to watch the wiring. So you might have to, depending on which fans you have, may have to cut some of these little tabs, locking tabs for the wiring, just so that the wires have room to fit. Which I'm going to, because I really don't want to yeah. I don't want the wire getting pinched. And again, these are just press fit in. They should fit relatively snugly in. And then on this one, there's a little wire channel on the side here, and it goes up and around. So same thing, I'm gonna cut the little tab here. I don't want the wire to get pinched. Don't cut your wire when you do that. And it will be tight, but it does fit. And so now the wire runs up, around, and out the side. And if you're curious, right there. But yeah, for cameras, going back to cameras, like for this guy, I'm going to try and use this one. I bought it on AliExpress. I actually bought it like before everything went to shit. It's one of those little, these little USB, I don't even know. I paid like $3 or $4 for this thing. It's like 15 FPS or something, but it's got a super wide angle lens on it. So I'm hoping I can find somewhere to mount it within the enclosure where I actually get a full view of the print volume and it's not sticking out, but I'm going to have to figure that out. I'd link it, but I don't know when I got it or where I got it from. Okay, so I need some M3 nuts here. And again, the little trick, if you ever need to get washers in somewhere and they don't exactly drop in, use a screw and just kind of push them down in. To pre-seat them before, or just use a longer screw and pull them into position. Okay, so we got our blower fans. So obviously we're going to have to cut these ends off. And they feed up and through, and then M340 holds it all together. Now I know I'm going to have to take the tool head off because I don't have the wires all in for the hot end, but just for demonstration I'm continuing on. I'll just do that in between because running the wires on this is kind of a pain. You really have to be careful running them because you can't have, and I'll point it out, you can't have any of the wires rubbing against the extrusion on your x-axis, and you can't have the them pushing against the belts either. So you have to be kind of careful with your wire management. Some hot end heaters won't work simply for the fact they have too thick of wires, or they don't the ferrule, like the metal part that kind of connects the end part to it, they don't fit, or they don't have enough bend or give to them, or they're in locations where you literally just can't make it work with what the room you got. There we go. So for wire management, you can see how they... Now this is just for your wires for your fan on the side. And now for the 30mm axial fan. That just screws in from the front. Or no. These are 25mm. Where are my 30mm fans at? Got a 12-volt sun on. Huh. Shoot. Why do I have so many little fans? They're not little enough. I'll just use this one for now. 24 volt. Just make sure you're using all 24 volts or all 12 volts or whatever you went with. Don't mix and match your voltages unless you know what you're doing. Yeah, okay, I guess I'm using a Runda good quality DC fan. This fan is going to be amazing, I can tell you already. If it's crap, which I think it is, I'll just swap it out. Okay, let's see. Catch up on chat. The TL thermistors and heater cartridges is a good alternative to the Slice Engineering ones. I'm using the Mosquito. I think I use TL thermistors, and I use Physek heater cartridges, the 50 watts. I think that's what I use at the moment. Okay, so for the wires, there's a little channel right here. It's kind of hard to see on this camera, but that's where the fan wires for your 30 mil go. So you're actually probably going to have to loosen this just to feed it through. Okay, there we go. There we go. And you're going to have to, let's see here. Yeah, you're going to have to cut the little tab again so that the wires come out the back. Now, when you have the wires come out the back, be careful you don't pull on them, because at that point it's really only the solder joint that's holding the wires in location. There we go. And what are these? M312s. Now these screws, be careful, because these ones are screwing into plastic, I believe. Yeah, these are screwing into plastic. So you really don't want to actually, no, we're gonna have to go longer. This one's a little thicker, I think. You don't want to strip the plastic out. Oop. PETG is terrible filming, yes. PETG is good for water bottles. Is a hot end fan heat set? Let me go back to the manual. Curious if we changed that. I know there was... Oh! Add threaded insert. Well, I'll be darned. We do have threaded inserts there. Originally it was threaded into plastic. And it was brought up that we should swap those to heat sets. So I guess we did do that. So, let me get my heat set set. Wow, I'm really running low on these. So I'm going to use the stupid little cheap ones. Because it's just holding in the fan. That's right, I remember now. Yeah, because they used some random oddball size there. So I'm breaking the rule. I'm using the really cheap heat set inserts just because I have like a bunch of them left. I want to get rid of them. Yeah, PETG, okay. As somebody who works in the plastics industry, tool and mold, PETG is not used really outside of 3D printing for anything structural. It's water bottles. That's the majority of what you find PET, and it's just PET. The G is glycol. It's added to make it printable. So PET is pretty much like for containers, like water bottles, stuff like that. You don't see it used as a structural plastic for pretty much anything. At least I've never seen it. I've never built a tool that ran PET. I've seen more tools using like PLA trying to do experimental biodegradable stuff. And honestly, ABS is an industry standard for a reason. And ASA is pretty much just ABS formulated for UV resistance, and it's a little bit easier to print, but it's pretty much the same thing. Okay, now comes the part where I try to put this in without screwing up all the other plastic parts around it. Okay, we're good. Yes. Okay, so basically, I might do it with switch wire because I've been meaning to do it for a while. Is how to print ABS if you've never printed ABS before. And cheat mode is literally going to be go buy eSun ABS Plus. It's not that expensive. It's relatively common, and it's a very good plastic. It is slightly springier than pure ABS, I found. But all my printers, all the black you see in all my Vorons is eSun ABS Plus, and I've never had an actual issue with it. And it's easy mode for printing ABS. Like, it is so beginner friendly, it's funny. Or it's not even funny how beginner friendly it is. There you go. Now, I'm pretty sure that you have to use flatheads here. Otherwise, it's going to hit the front of the enclosure, but I don't know if I'm going to enclose my Vzero. If it hits, I'll swap it to flatheads. And if it doesn't, I'm not going to bother. Okay, take this back up. Oh yeah, the German Voron group, they buy, like, I buy it by the case, they buy it by, like, the shipping container. They love their eSun over there. But it's good plastic, don't get me wrong. It's very, and you know what, it gives you this nice matte finish. It's a very matte finish. Actually, this tool head came out pretty good. So, with the drag it in, and when you go to install your hot end, just make sure that you have it like this way. If you have it this way, you're going to melt your fan. So, there's the tool head. That is so tiny. So obviously I'll have to take this off and install it later, but not a big deal. Oh god, ABS fumes. Don't get me started on ABS fumes. It should come in blue. The blue in Tallboy is eSun ABS Plus. I think I'm out of it though finally. Yeah, well, Prusa used ABS until they switched to PETG. They used it for they went to PETG mostly for the fact that they didn't have to deal with warping issues. They didn't have to deal with having an entire room running at 40 degrees Celsius. It's more reliable, although you can print ABS faster. I've worked next to 3,000-ton injection mold presses. Now, granted, they're not running all the time, but in 1 hour they go through as much plastic as somebody doing PIF will probably go through in a year. Okay. So, now we've built the tool head, so let's go back up the manual. And by built, I mean almost built. It's got to come apart. So let's see, where do we leave off? Okay, see appendix for toolhead. Okay, so we have two M335s, and that screws into your belt holder block thingy. And then you have M28s hold it to the carriage. So that's kind of a cool design because you can do an almost quick hot swap of the tool head. Oh god, that guy on Reddit, I was like one of the first people to call him out. And it's like, yeah, I can kill you. I'm like, okay, here's the thing people need to understand. It's all about percentages and exposure, okay? Arsenic will kill you, but you actually have an extremely small amount of arsenic in your body right now. Like, smoking will kill you, but walking by somebody who's smoking once in your entire life probably isn't going to give you cancer. It's all about exposure and like amount and frequency, basically. Okay, so that's actually really tight on there. I'm gonna have to trim that down. Where's my knife? So anyway, so yes, you know, ABS does give off harmful chemicals and whatnot. The thing is, will you get enough chemicals from being exposed to a 3D printer in the same room as you to cause any sort of actual effect in normal use? And by normal use, I mean like most people don't sit in a room with a 3D printer 24/7. Okay? So unless you're doing that, what are the odds that you're actually going to get exposed to dangerous amounts compared to somebody working in an injection mold facility working next to a press that's shooting 8-pound front fascias all day, every 2 minutes? An 8-pound fascia comes out. Like, I'm pretty sure they're going to get exposed to a lot more fumes than you. And they can sit there all day without having to wear a mask because the ministry says, oh, your air is fine. There we go. So I'm going to have to shave that down, obviously. I gotta cut that more. I might have to swap these out to button heads. We'll see. I hope not, because that's going to be a pain in the arse. Oh, no, we're good. Okay. Okay. That ain't gonna work. Shoot. So in my rush, I have M8 or 8mm long screws here on that little block that holds your belts. And unfortunately, they are hitting the rail, so I cannot use those. Or they're hitting the extrusion, so I'm going to have to try and swap these out. So let's see how easy this is. So what I'm going to try and do, I wish I had a clamp. I have a clamp. We do have a clamp. I'm hoping that stays so that I can undo the screw and put the new screw in and not have to redo all my belts, because if I do, that's going to be it for the night, and that'll be something I do on my own time later. And I'm not screwing it into anything. Dang it. It should be right there. I think something's screwed up here. I think these belts are either too thick or something's wrong, because I am using the right screw. 138. I'm using M36, that's why. Or no, it is supposed to be M36, yeah. So why the heck is this screwing in? So what it is, that'll do it. So the way I have my Maker Beam T-nuts orientated, they actually have a chamfer on them. And the way the chamfer is, that's why I'm not getting a bite. because of the way the chamfer is, it's not screwing in because it's not being able to engage when it normally would engage and then pull the rest in and be able to tighten it. So if I spin it around, will it work? I can feel it, it's wanting to. No. No. Let's see. Yeah, the stream's about to get a little boring. Yeah, the problem with the 8mm ones, though, is they're pushing against the extrusion when you go to screw everything in. So it can't be 8mm. Does ABS absorb moisture? Yes, it does, but for example, like, I keep my ABS out, and I haven't had any issues over 6 to 8 months of it being out and about. Now, if you're leaving it, like, outside, and it's raining out, or you just live in a humid place, or your house doesn't have climate control and it's just humid in your house, yeah, you know, buy a cheap little $20 or $30 used food dehydrator and go to town, use that for drying it out if you need to. But basically, if you feed it in and you don't see it popping and bubbling, you shouldn't have to worry about drying it out. So a good way to tell if you need to dry it out is try printing with it. If it doesn't crackle, you're fine. So. That's what I would say. I have no idea how... Okay, screw it. I'm going to rebelt this. Because I cannot get this working right. I don't know why I can't get proper engagement here. But it's just not working. So this is the problem I'm having. The longer screw is 8mm, the shorter one is 6. And the problem is I can't get the belt through there and start screwing there. Basically the belt holds the nut up too high, and these nuts don't start right away. Like, I had it the wrong way around. Like, if you look at it, you can see how soon it starts with the thread. But then if you flip it around, it sits like almost halfway in. It's kind of hard to see. So basically what screwed me there is the fact that I had them with the chamfer facing inward, which is what you'd think you would want. And because of that, I couldn't get threads to start, so I went to an 8mm. And because I went to an 8mm, it's contacting the gantry, and it's not working. So we're going to try this again. It's going to be one of those nights. Hey, at least I haven't electrocuted myself. Flashback to the V2 stream. Okay, so you go there. Mr. Toolhead can go there. Won't be needing you probably for a while. Let's see here. Let's see if I can sort of get one of these started in a controlled environment and go from there. So I go with the nut, put that in. Put that in. Give it one turn. Okay, so it's engaged. Okay. Now can I feed this back through underneath? Nope, it'll pop right off. I don't like the way these nuts are manufactured. The way these are manufactured, they have, I don't know if I got a bad batch of them, but the fact that they have a lead on something so thin means you lose thread, you lose contact, and that's a huge thing. So that the fact that I can't really get threads to start until halfway through the nut on some of these makes it a really crappy nut. So that's what screwed me. Let's try some new ones. So that one's engaged. Okay, that's engaged. How much do I have? I got like nothing there. Yeah, I can't believe how I do not like the way these are manufactured. Take some plastic off the grooves in the housing. Yeah, I'll probably end up doing that actually. I see where it would be a good way to do that, or good location. So if you look at it, this little ramp out. Now, I don't know if these issues I'm having is because I'm not using the proper belts, or because the plastic that I used to print this, I haven't really tuned properly. I literally just kind of threw it in and printed it. And the parts are a little over extruded, I will say that. What am I doing, Dr. Knight? I am trying to figure out why I can't get these belts to kind of grab where they gotta go. We're having a fun night. And dealing with poorly manufactured nuts. And another reason I hate button heads is they strip super easy. We are not having a good stream today, guys. Oh, it's just a clamp. This is just a clamp. So this is the problem. So this is an 8mm screw. And the 8mm works, okay? The problem is it sticks out past the back, okay? It can't do that. So I don't have a Dremel or a grinder at home, unfortunately, so I can't just kind of lop it off. But it just won't engage properly. Where to put that other? Now let's see, maybe if I use... Try M38 with a flathead. See if that does anything. You know what? That works. Yeah, M3. So a flathead works. An M38 flathead works. And it doesn't stick out past. So I think we're back in business there, boys. And potential female. According to YouTube analytics, there's like one. It's only a 99.9% sausage fest on my channel here. Okay. Yeah, unfortunately, in terms of like it being a complete pain in the butt, it's like a nature of the beast thing. If this part was any thicker, we would lose room on your x-axis. Or y. Like, there is literally nowhere where you can squeeze any more room in this printer. Cam, I'm just running belts. For some reason, this wasn't that big of an issue originally. I remember this being a pain, the original build, but something changed, I think, and I can't remember what. wish I remembered. Yeah, it's Kodak ABS. That's the orange I got. And I don't think it's actually manufactured from Kodak. I think it's just kind of a branding thing. It's made in Argentina. But it was cheap. And by cheap, I mean like $20 for 750 grams. And it's actually a really nice orange. There we go. Okay. Okay, you go there, you go there, you're on there, you're on yours. There we go. That goes up, that goes there. Flip it again. Okay, so now, actually, loosen these off a bit so I can get the dang annoying thing in. Okay, so hopefully this one goes on as easy as the other one. Dang it. Just not want to engage. Try a different one. I really do not like these T-nuts, or whatever the heck these. Yeah. There we go, that's what I want to see. And just cross threading. And that one doesn't want to screw in. These are the worst T-nuts ever. And I just ripped the thread out. Shit. Where's the vise? Where's that clamp I was using? I think that helped a little bit. Yeah, I do not like the way these are made. Holy shit, we have proper thread engagement. Proper enough. Okay. I think we might actually have it now, finally, guys. Good enough. Okay. Nothing's sticking out the back. Okay, finally. Holy hell. Yeah, this old house. I'm gonna need this old bottle of booze after this. I think I got whiskey rye and I got white rum. So it's either rum and coke or just some whiskey rye. Or rye whiskey. I think it's just rye whiskey after this. Okay, let's get this tool head on so you guys can see what it looks like. Coming up on 11. Thank God I didn't put this on backwards. If I put it on backwards, I would have been like, okay, we're done. We are done. I'm going home. Yeah, because of this old Tony, I'm looking at getting a mill. I would love to have a mill. I just want one of those little itty-bitty ones that people turn into CNCs. Problem is, I have Bridgeports at work I can use, so I can't justify buying a mill when I can drive to work and use a Bridgeport. Okay. So I need M3/8s, or M2/8s. You know what though? A CNC conversion, I got nothing against CNC conversions, because a lot of time if you're converting like an old Bridgeport or whatever to CNC, it'll probably be a better CNC than most cheap CNCs, simply for the fact that it's rigid as all hell. So yeah, it might be slow and heavy, but I guarantee you it'll be rigid. Man, these guys don't want to go in their holes. Do I have a small enough? I do. Okay, so here's my opinion on the Voron CNC. We're not doing a router. It's going to cut steel, which means you're all going to have to go buy a welder. Because, like, most, like, MP CNC and the other, like DIY home CNCs built with 3D printer parts, like, they're routers. You're doing, yeah, you could do wood. Yeah, you can do some light aluminum. Oh, some of them, you can cut steel on an MP CNC if you're, got a crazy 20 million Rip'em spindle and you're using like a 2 mil ball taking like 2 thou depth of cut. But you're not hogging, P20 tool steel on it with a 5-inch fly cutter, or doing a 72 mil sumo drill at 12 inches a minute. Like it's not. You know what I mean? Okay. There we go. Okay, what did I hit? That's the mute button. Okay. When did I lose audio? How long did I lose audio? Okay, so if you missed it, I built the little stream deck. That's what I use for like changing cameras. Is this little guy, and this button is the mute button, and I bumped it under the monitor. So might as well start over. Okay, cut the belts, and we'll do that all again. No, everything feels good. What I was talking about with earlier, you got to be really careful when you're running your wires up through the channels that you're not pushing. It's gonna be hard. Might be able to get the angle. That you're not pushing these belts into the extrusion, and they'll rub. because you literally only have like this doesn't fit through it. You have 2 millimeters of clearance, so you really do not want to be pushing your belts into that. So when you run the wires, you got to make sure they're nice and tight against the housings. So there we go. And this is why you can't use button heads, is because when you got your panels and your panels go on, they hit these socket heads. So actually, even button heads. Yeah, so I don't think this fan is spec. But yeah, you're going to hit the front panel. Okay. Screw it. Let's see, finally, what is next. Oh, I put these top ones on. Okay. Oh. 1 second. Never mind, I thought I heard the dog. Okay, so these guys go on top here. Now, if they don't fit in, you might have to loosen some screws and just kind of make them fit. That ain't gonna fit down there. There we go. Oh, I forgot it's one of those ones. There we go. Okay. So what do we got? We got, oh, I got to put 3 nuts in this on the outside. So that's for your panels. 2, 3. One, two. Two, 3. And let's see what size screw we need. M310. Good old M310s. Which I think I'm running low on now. Oh, no, I still got one. There we go. There we go. I gotta remember to change the camera when I'm working on stuff. Voron 3-axis bed and stationary extruder when? Well, what you do is you take your bed and you glue it to your hot end. Okay? And then you take your hot end, you glue it to your bed, and you're done. Well, honestly, here's the thing with print quality. If you could get your settings tuned right, I'm sure it would print perfectly good. It would just be slow. And that's what a lot of people don't realize with like 3D printers. For the most part, they all print good nowadays. All printers will print a good Benchy, for example. The thing is, will you take the time to tune it properly? As long as it doesn't have mechanical issues like lead screw wobble, some can just print faster than others, or some, have different quirks and whatnot. But for the most part, I mean, a hot end's a hot end. A V6 is a V6. A NEMA motor is a NEMA motor. An extruder is an extruder. Some are more accurate than others, and some can do, have more bells and whistles. But for the most part, we've kind of peaked in terms of like 3D printer quality. An Ender 3, go to r/3D printer on Reddit, and every day you will see, look what my $170 Ender 3 can do. Oh my god, I am so amazed. Why would I ever spend more on a printer? Well, one, because you want a printer that doesn't have a bed that you can, get your little skate deck and do kick flips off of, because it's so warped. But you can print good on any 3D printer. It's just some you can do a lot more than just print good. You can print good and fast and reliably and, enclosed with ABS and all kinds of other fun stuff. So, okay. So at this point, I'm going to call it for the night. So as always, for the next, what time is it? It's 11:10. So for the next like 10 minutes or whatever while I clean up, I'll leave it open if anyone's got any questions. Oh, this is what I wanted to go over. Okay, let's see how I can do this. So we're going to zoom in on Tallboy here, because I want to go over something that I kind of found out here. So I just put the flex plate on, and it's an energetic one. Now, I know there's like Wham Bams and all these other ones, but I live in Canada, so I can't get it. Oh, hold on. That's fine. So I can't get a lot of the fancy stuff. I can only get what's available in Canada, or it ships to Canada relatively cheaply. So this is an energetic system. Now, I know a lot of people have been saying that with energetic, they've been having issues with the mag plate not sticking to the bed properly. They've had issues where it's like popping up. When you print a lot, you're seeing it. Oh, wow, that's really slow. You're seeing it like the corners curl up. So I've been running an energetic flex plate system on V226 here for the better part of over half a year now, and I've printed hundreds of hours of ABS and I've had zero issues, and like it sticks really good. Like I've never had this peel up, and it's literally just the spring steel plate with their cheap little thin PI on it, and it sticks great. Like you can feel it. It wants to fall down. This one is their same thing. It's the flex plate with the textured side, and I think that's the problem, because this one, like, it's floppy as all hell. I know the lighting's kind of bad over here. Let me see if I can get it better. So I think it's not their magnet that's the issue. Now, if the magnet dies, right? Like from the adhesive. But that one I haven't had any issues with. But like this one, it's crappy. Now, here's the thing. Months ago, well, actually over a year ago, when I was building this guy originally, I bought off Amazon. It's like an Airy one. I don't know. It's a cheap, like $40 spring steel magnet and flex plate. I never used it because the magnets are probably shit. But the flex plate is just spring steel. Now this one, it sticks. It feels the same like this one. And when you go to measure it, I'm going to zoom back out here. So when you go to measure it, right? Now, yes, I am measuring with the PI, but this one's about 70 or 0.7 mil. The good one that I know is good with the PI is 0.8 mil, and this is energetic. Now, the textured spring steel one has a PI sticker on one side, texture on the other side, and it's 0.8. But without the sticker, it's 0.5. So, how much of this is actually steel? Because the texture is relatively high. Like, I think there's one, if I can find an area where the texture is not. What I'm trying to say is I think either the steel that they use is either too thin or it's, like, cheap. Like, it's not enough, it's not ferrous enough. Because I'm finding that these flex plates that don't have the texture on it are much more grippy to the magnet. Even like the PI side down. So what I'm actually probably going to be doing is I have some energetic PI. I'm going to slap it on this plate, peel off this, because that does not look like PI. That does not look like PI. Peel off this crap and put proper PI on it and not use this, or just use it for like small textured bottom prints. Because this, like, that does not feel good. For this one, like, so I think that's why so many people are having issues with energetic, is it's not the magnet, it's the flex plate. So I have some PI that I'm going to put on this and use, probably. But I think that's the issue, is it's the flex plate, it's not the magnet. Because I've had the magnet on this one for 7 months, 8 months now, and I've printed hundreds of hours of ABS, and it's not peeling up, it's not stinking. I haven't had any issues. When I do the video, which I've already filmed on how to apply the magnet, I go over some steps on how to make sure your magnet is properly adhered to the bed. A lot of people just kind of slap it down. But yeah, I think that's the issue a lot of people are having. I just came across that when I put it on. I could just tell it wasn't feeling good. So I'm thinking that's their problem. So yeah, so let me catch up on all the chat on that. Oh yeah, the double face not have enough good surface. Well, it's not the double face, because either side, if I flip it down, like right now it's PI down, and on this side it's the textured side down. And honestly, they feel about the same. So I think because the metal is either thinner, or the way they treat it, or it's something with, like, because it's got a when they adhere it, they I'm pretty sure they heat the metal up, and if you heat metal up to a certain point, it loses magnetism. So I don't know if it's a process or something that it undergoes, but I think just straight spring steel with a sticker is the way to go, because it adheres better. Now there's Wham Bam, there's like proper ones that work great, use those. But I'm talking for like the cheapo ones. If you're gonna buy cheap, just get a spring steel with PEI sticker, and don't bother with the texture, because like even Switchwire has, well, the Switchwire has a Mark 52 bed, which is the Prusa bed, and that one's got a textured plate. The texturing, I don't like it. It doesn't stick as good as I find PI sticker does. But the magnet, it sticks. It ain't going anywhere. So, but yeah, I don't know if I just got a bad one or what, but that's kind of like my little thing I kind of went over today. So anyways, okay. So that's the rant. If anyone has any questions, go ahead and shoot them while I'm giving everything a quick little cleanup here. And I'll be wrapping up soon. Next week, I gotta do pocket watch. I'll probably just do the pocket watch as a video, like a standalone video, and then I'll get that all installed. And then next week we'll do wiring. So I'll have the actual tool head, hopefully the Dragon installed. So I'm just gonna pop it in there for now, so I can take a picture. Let's get in there. Have I seen a V2.X printing, well, 2.85 millimeter 3mm? It was, somebody was asking about it. They modded a Mobius to print 3mm filament. And honestly, it wouldn't be that hard. You would just need a hot end that can do 3mm, and you would just need an extruder that can do 3mm. You would have to mod the whole afterburner to do 3mm, or if you were doing a Bowden setup, you would literally just slap any extruder on it and apply any hot end that uses 3mm. So there's nothing stopping you really from going with 3mm filament, except for the fact that 3mm filament's kind of dying out. Will you go microfit? So I'm going to wire this up how I had it originally, where because it's such a short run, and I use the spiral sleeving, I wire directly from the hot end to the controller. So when I go to wire it, I'm going to be cutting these wires and like soldering on proper extension wires. But I'm literally just going to run straight wires all the way down. Now the motors have connectors, microfits, for maintenance reasons. But for the most part on Voron's Vzero, because it's so small, I just run everything direct down to where the controller will be. And then if I need to do anything, I can just undo it all. It's a little bit more work, but I find I would either have a mass of connectors here, which is like literally 6 inches away, or I would have a mass on the tool head, which would look ugly. So I just run everything direct, and that's how I did it originally, and I didn't have any issues with it, so I'm just going to keep doing that, I think. Okay, so I think I'm going to end it there, guys. So, as always, thank you all for joining me tonight. I know we had a little bit of a hiccup there when it came to the belting issue with the belt retainer, but we powered through. We got that done. I did get as far as I wanted to do. We got the printer basically assembled at this point. So next week, move on to doing electrical. We'll be doing some wiring. I don't think we'll get to the point where we're going to have movement, but hopefully we'll have everything wired up and it'll look like a fully finished printer at that point. I don't think I'm going to go as far as going over the enclosure, because I don't know if I'm going to enclose this guy yet. I didn't before, and I have two V2s for printing ABS if I need to print ABS. So this guy will probably be, you know, backup and a PLA, little doodad machine. But that's where we are right now. So as always, thank you for joining me. I hope you all have a great night. Enjoy the rest of your weekend. Be safe out there. Wash your hands and wear a mask. And take care. Peace.